Welcome to Homework Lib.
Question.
Observations from foam reaction experiments. Several trials were conducted using combinations of hydrogen peroxide, yeast, vinegar, baking soda, beer, and dish soap at varying temperatures: cold, room, warm, and hot. Each experiment documented the following: starting temperature, time for reaction initiation, foam height, reaction behavior over time. Explanation. These experiments were designed to explore how different temperatures and reactant combinations affect foam production. Foam height and formation speed serve as proxies for reaction rate in decomposition and neutralization reactions. Summary table. Table note. Experimental conditions. Starting materials. Temperature, greases, time points, observations. Overflow in 2 sec. Slows by 2 min. Nearly at 3 min. 6. High temp H2O2 plus yeast. 40 milliliter H2O2 plus 2 pipettes yeast. 44 degrees Celsius. 1 min, 2 min, 3 min. Overflow in 2 sec. Slows by 2 min. Nearly stopped at 3 min. 6. Hot temp H2O2 plus yeast plus dish soap. 40 milliliter H2O2 plus 10 drops dish soap, 2 pipettes yeast, 44 degrees Celsius. 2 sec, 1 min, 5 min, 10 min. Overflow in 2 sec. Runny foam. Slows at 5 min. Thick foam by 10 min. 7. Room temp beer plus sodium bicarbonate. 40 milliliter beer, 5 rum HCO3, 20 degrees Celsius. 1 min, 2 min, 3 min. Bubbles immediately. Slows at 2 min. Reaction nearly stopped at 3 min, 23 degrees Celsius. 8. Cold beer sodium bicarbonate. 40 milliliters beer plus 0.5 NaHCO3, 14 degrees Celsius. Instant 1 min, 5 min, 10 min. Instant bubbling. Foam 12.5 centimeters. Slower than room temp. Thick and milky. 9. Room temp. Apple cider vinegar plus baking soda. 100 milliliter vinegar. 5.3 grams baking soda. 20 degrees Celsius. 1 min, 2 min, 3 min. Bubbles at 20 degrees Celsius. Still flowing at 2 min. Slow but ongoing at 3 min. 10. Warm apple cider vinegar's baking soda. 100 milliliter vinegar plus 5.3's baking soda, 27 degrees Celsius. Foam reaches 500 milliliters mark. Exact time not recorded. Hypothesis. If the temperature of the reactants increases, the rate of foam production will also increase. Higher temperatures raise the kinetic energy of particles, leading to faster collisions and reactions. Combinations like hydrogen peroxide, yeast plus dish soap will produce more foam than vinegar plus baking soda, or beer sodium bicarbonate, due to the catalytic action of yeast on hydrogen peroxide. Scientific explanation. This hypothesis is based on the collision theory of chemical kinetics. Higher temperatures equals faster molecular movement equals more effective collisions. Specific reactants like H2O2 plus yeast plus dish soap produce foam through rapid oxygen gas release. Conclusion. Based on observations, hot hydrogen peroxide plus yeast produced foam in just 2 seconds, confirming high reaction speed at 48 degrees Celsius. Room temperature reactions like beer plus baking soda or vinegar plus baking soda began immediately but slowed within minutes and did not overflow. Foam height was significantly lower in cold reactions, showing reduced reaction rate. The most vigorous reaction, hot H2O2 plus yeast plus dish soap, apple cider vinegar plus baking soda, showed slower but consistent foaming. Final summary. Hypothesis. Increasing temperature increases both foam production rate and volume due to faster reaction kinetics. Combinations of hydrogen peroxide, yeast, and dish soap produce the most vigorous foam. Conclusion. Higher temperatures, faster and taller foam production. Yeast plus hydrogen peroxide plus soap gives most intense reaction. Room and cold setups equal slower, less foaming reactions. Reaction temperature and reactant type strongly influence the foaming behavior.